Let's continue with our discussions on electrostatics. As a review, we have learned that charged bodies will exhibit attraction or repulsion forces. And the basic law states that like charges repel and unlike charges attract. And this attraction and repulsion was clearly defined or quantitatively defined by Coulomb, Charles Augustin de Coulomb, in his famous Coulombs Law. And Coulombs Law states that the force between two small charge bodies, so it refers to two small charges, acts along the line joining them and is directly proportional to the product of the two charges and inversely proportional to the square of the distance between them. In symbol, so this is equal to F. This is the force of attraction or repulsion, and this is equal to the product of the two charges, the magnitude of the two charges, directly proportional, but then inverse to the square of the distance separating these two charges. And this K is the proportionality constant. So let's define the terms. So F is the force of repulsion or attraction. The Q1 and Q2 are the two interacting charges. And R is the distance between these charges. This is the line joining the two charges. And K is the proportionality constant. It depends on the units employed. So again, repulsive force if charges are alike. Example, if the interacting charges are both positive, so positive, or both negative. Joke. And if attractive force, if charges are unlike, example, positive and negative, or negative and positive. The resulting force in this case is negative force. So meaning, if negative force, charges have different signs, and thus attractive. Okay, for the corresponding units, column C for the unit of charge. The charge, example, the charge of an electron is equal to 1.6 times 10 to the negative 19 coulomb or C. And for F, of course, since it is a force, it has a Newton unit or capital N. And R, since this is a distance, so let's use meter or M. And K, this is equal to 9 times 10 to the 9 Newton meter square per coulomb square. K can also be expressed in terms of epsilon naught, where this is the permittivity of free space. And it has a value equal to 8.85 times 10 to the negative 12 coulomb square per Newton meter square. As you can see, this is just the reverse unit of our K, so we can express K in terms of epsilon naught, or this is equal to 1 over 4 pi epsilon naught. Thus, our force of attraction or repulsion between two charges can be written in this manner. 1 over 4 pi epsilon sub O Q1 charge 1 times with charge 2, and then over the square of the distance between them. So this is our Coulombs law equation. Let's consider a specific example. Example 1. A point charge of positive 2.0 times 10 to the 6th coulomb is 15 centimeter distant from a second point charge of negative 1.5 times 10 to the 6th coulomb. So calculate the magnitude and direction of the force on each charge. Let Q1 be equal to positive 2.0 times 10 to the 6th coulomb, and our Q2 is equal to negative 1.5 times 10 to the 6th coulomb. The R12 equal to 15 centimeter, or this is equal to 0.15 meters. And the distance between charges 1 and 2, or from charge 1 to charge 2, is also equal to the distance from charge 2 to 1, or to 1. And this is also equal to 0.15 meters. And the notation F12, this is defined as the force on Q1 due to charge 2. In the same manner, F21 is the force on charge 2 due to charge 1. Let's draw the FBD. So based on the free body diagram, or FBD, if this is the position of our positive Q1, and this is the position of our negative charge Q2, then this force represents, by definition or by our notation, this is our F12, or the force on our charge 1 due to charge 2. And this is also our F21, or the force on charge 2 due to the presence of charge 1. So as you can see, forces, or this force is attractive. F12 and 21, they are attractive. The distance between these two is labeled as R12 or R21, the same, which is equal to 0.15 meters in magnitude. So computing the magnitude of forces F12 or F21, by definition, F is equal to K, the interacting charges, over the square of the distance between them. And this is plugging in the values. We have this value for our constant K times the Q1, which is equal to 2 times 10 to the negative 6th coulomb, and then negative 1.5 times 10 to the negative 6th coulomb, all over our distance, all over the distance between them, 0.15 meter square. So this is equal to, the force is equal to negative 1.2 newtons, and this is attractive. As you can see, the sign is negative, and that this force is therefore equal to F12, 1.2 newton towards Q2, and F21 is also equal to 1.2 newton towards Q1.